All right, so like I said, today we're putting together all of our right triangle skills and putting them together into one big problem. So for right triangles, we've used Pythagorean theorem, we've used the special ratios for 30, 60, 90, and 45, 45, 90, and now we've just learned some trigonometry. All of this is going to allow us to solve any right triangle given two pieces. What your goal is now is to look at what you're given and decide which of those three methods you need to use to figure out what the rest of the information is in that triangle. Okay? So the biggest trick here is looking at what you're given and deciding what method is going to be best. Pythagorean theorem, 30, 60, 90, 45, 45, 90, or SOHCAHTOA. One of those three. Okay? So the terminology that we're going to be using today is we are going to be looking to solve any right triangle given two pieces of that triangle. The right angle is always given to you because we're assuming that it's a right triangle, so I'm talking about two additional pieces. How many pieces total are there in any triangle? 6. So you have 3 angles and you have 3 sides. So you're going to be given the right angle no matter what, and then I'm giving you 2 additional pieces of information, which will leave you with 3 more pieces to find. All right? So I'm going to kind of talk you through the scenarios that you might come across when solving these types of problems. So you might be asked to solve a triangle where you are given what? Multiply 11 by each side. Yep. So I will times by 11 over here to cancel, and then times by 11 over here to keep it a balanced equation. So this is one of our nice ones where we don't have to do any extra work now because we've got 11 cosine of 40 equals A. Can somebody type that into their calculator and let me know what they get for A? All right, so I now know what A is, and I have left to find, shoot, 1 second. I have to figure out how to make it stop closing in the middle of my presentation, huh? Okay. Okay, so now we have to find B. And this is what Derek was just asking was, can I look at the opposite side of the angle 40? And you can, except for now that'll find B instead of A, right? Because if I look, where am I? I can't find my arrow. There I am. If I look opposite of B, that's going to find the little b, and then what would I put that with? The hypotenuse 11. Why do I not want to use A? I have a value for A now. Because it's an approximation, it's not exact. And remember, we don't want to use approximations to find other values along the way. All right, so if I'm going to be setting up my sine business, I've got sine of angle 40. Is that really small? Yeah, it is. Sorry. I've got the sine of angle 40 equals the opposite side, which opposite of 40 is little b, over the hypotenuse, which is 11. And then we go through very, very similar steps as last time. Multiply by 11 to cancel. Pick it up on this side. And now we've got that b is going to equal 11 sine of 40. Can somebody give me that approximation to 4 decimal places? What? Yeah, it's a sine, so it should be different. Manasa? Okay. Have we solved for the entire triangle now?
Yes.
Yes, because you now know all three angles and you know all three sides. Joey?
If we're solving for B, could we switch the angle if it's easier for us to use 50?
Yeah, absolutely. As long as you use it properly. You can use whatever you want. Okay, so another problem that's going to look similar to this, but that's slightly going to have a different method. And I'll tell you why it's similar and why it's a different method in just a second. So let's say that I give you this triangle. What is similar about it to the other one? About the given information, what's similar? What was that? It gives you a side and it gives you an angle. What is different about this one, though? They're both acute.
Oh, wait, sorry.
I gave you a leg instead of a hypotenuse. It's a 60, 30, 90. That's the big one, is that this one is a special triangle. Okay? While you can technically do trigonometry on this triangle, like you could set up a sine of 30 degrees or a cosine of 30 degrees, remember that whenever we use trigonometry, we're having to round our values, right? And that's bad if you can avoid it. The last triangle we just did, we couldn't avoid it. There was no way to avoid getting those solutions without having to do trigonometry and round. Is there a way for us to solve this triangle, though, without having to round? Using your ratios, you can get square roots, right? So you should, if you can, give me an exact answer. And I will expect that on a 30, 60, 90 or 45, 45, 90, I'm going to expect you guys to recognize that I want to see ratio work there. You will not get any credit solving a 30, 60, 90 triangle with trigonometric methods. I'll be seeing that in other triangles. So when I get to a problem with a special triangle, you have to recognize that that's what I want to see. Okay? That's kind of one of the tricky parts. All right, so to do this problem, let's go ahead and put some variables on those sides that we're looking for. So I'm looking for this side and this side. Since this is a 30, 60, 90, I'm going to go ahead and use my ratio. So I'm going to run around the figure and put my ratios around. Where does the 1 go? By the 3, what goes by the x?
Root 3.
Square root of 3 would go by the x. What would go by the y? 2. Okay, so are we at the home base moving forward, or are we moving back to the home base? We're at the home base and we are moving forward. So I can take my 3, and I can multiply forward and get to the root 3 just by simply multiplying by root 3. So this side is going to be 3 times root 3. The hypotenuse, very similar. I'm starting on the home base, moving forward to the side 2. So you multiply that and you get 6 for that side, and we're done. So actually, if you recognize those 30, 60, 90s and 45, 45, 90s, there's a lot less work involved when you see that it's there, right? Okay. The last type of problem that we get is, give me 1 second. So the last type of problem that you can have is given 2 sides. So for an example, if I give you that. What are your thoughts? Matt? Sorry, what was that? How are you getting 9 without any work? It is, but that would end up being 6 root 3. Shoot, that's not what I wanted it to be. We're going to retract that 12, and we're going to make it 7 so that it's not a special triangle. Now what? Pythagorean theorem. You know two sides, right? Okay, so we should be setting up Pythagorean theorem to find this bottom edge. That will give me x squared plus 6 squared equals 7 squared. That is x squared plus 36 equals 49. What's 49 minus 36? So then you're going to get x squared equals 13, which means that x will equal square root of 13. And can you simplify that? No. So now the issue is, how do you find your missing angles? Because that's the part that I haven't taught you yet. So in the case where you know two sides and you need to find one of your angles, go ahead and label your angles as something. So I'm going to label this as angle A and angle B. Okay. You set up a trig ratio here, and you kind of do an inverse thing. So if I wanted to find angle A, what are the two numbers that I have that are the nicest numbers on the sides? Yeah, the 6 and the 7, right? Which, just like Miriam just said, we've got a 6 and a 7, which are adjacent and hypotenuse. Adjacent and hypotenuse would be which setup? So you would set up the cosine of angle A is equal to 6 over 7. I'm going to kind of go through this kind of quickly. You're not going to have homework on it tonight, so just take a look at it, recognize it. I'll start the lesson by re-going over this tomorrow. The main idea is that your variable is within the cosine. You want to move the cosine, but we can't divide by just cosine without the angle being attached. All right? So what you can do is you can move the cosine over here if you put onto it a cosine, and then this little to the -1 is what we call an inverse sine. Look on your calculator, see if you can find it. I'm going to stop right there, and I'll continue on this tomorrow, and I'll keep on going with this inverse thing, but you'll see on your calculator that you have that button. So from here, you would just punch in on your calculator, cosine inverse is 6 over 7, and it will give you a degree. Okay? What? Oh, you got it? Okay.